Welcome to video 5. Congratulations, you've made it past the halfway point on this long video series. We're almost there. We're going to keep going. This is just going to be a short little video that's going to go over some of these special situations that you might run into when you're graphing. We're going to cover 3 main situations that you're going to run into that have kind of special situations that don't really look like anything else that we've looked at. So the first example, example 5 we're going to look at, there is no m or b in the problem. We are just given y equals x. So we normally would start with our y-intercept, but we don't have one in this problem. There's no b. We have to do a little bit of critical thinking to help us figure out what the y-intercept is. Remember, our b is something that we add to that x value. Now, we only have an x there, so we need to add something that's not going to change the x. The only thing that we can add to an x and not change it is a 0. So this is going to mean that our y-intercept is going to be the origin, because remember, our x value for any y-intercept is always 0, and then 0 is the only b value that we can add to x that does not change it. So we're going to have our y-intercept at 0, 0. Now if you think back to earlier lessons in this unit, whenever we did not have a number in front of the x, we always put one specific number in there. Do you remember what it is? That's right, we always assume that there's an invisible 1 there. So that means our m is actually going to be 1. If we were putting that in fraction form, that would be 1 over 1, which means we're going to be rising 1 and going to the right 1 as well. And we're going to keep doing that as we go across until we have enough points to go ahead and draw our line. Remember, we want arrows at the end of both so that we know that this goes on forever. You're going to use your ruler to help you draw the straight line. And that is going to be what a problem is going to look like if there's no m or no b. The next problem is going to be even more of a unique situation. What happens when you don't have an x? When you just have y equals 3? If you remember back to what we very first said in the very first video of this lesson, the whole reason that we're graphing is to show solutions. Every single solution that's going to make this statement true, this equation true. If we are given y equals 3, we need to draw a line that is going to show everywhere that our y value is equal to 3. So what I'm just going to do is pick out some points on this graph that's going to make this true. Remember, where y is 3, that would be anywhere that we're counting up 3. So I'd count up 1, 2, 3, and I'd have a point there. But that's not the only place that y is going to be equal to 3. I could also say there, because that is 3 above. I could go over here. What I'm going to find is that if I were to draw a horizontal line here that goes from left to right, every single point on this is going to be 3. Alright, to give a little bit of an algebraic background on this, remember our slope is rise over run. If we were to look between points here, I would be going up 0 and over 1 each time. Up 0 and over 1 each time, which would be a slope that looks something like this. Now if I were to write it in slope-intercept form, y equals mx plus b, anytime that I have 0 on top, that's going to give me 0. And 0 times anything is always 0. So that is going to be why an equation that looks like this with no x value is always going to be a horizontal equation. And I'm going to give you the first half of a memory trick that will help you remember this. We're going to talk about something called Hoy Vux. Now, I'm going to go ahead and focus on the Hoy part right now, and then in the next example, we'll look at the Vux. Alright, in this, H is going to stand for horizontal. Whenever we have a horizontal line, we are always going to have a slope of 0. So 0 is equal to our slope. Finally, it's always going to be in the form of y equals some number. Anytime you see y equals, we know we're going to have a horizontal line with a slope of 0. Let's go ahead and look at our final example. What happens if there's no y? This is going to be very similar to example 6, but instead of looking for places where y is equal to that number, we're going to look for places where x is equal to that number. So the first most obvious place is going to be right here, -2. That means that every point here is going to have an x value of -2. If I keep going to the left in different places, that is going to form a straight vertical line. It's going to be up and down instead of left and right. So when I draw this line in, it is going to look something like this. Now the algebra is a little bit more confusing on an example like this. In this case, we are going up 1 and over 0. But that brings up a problem that we're not going to worry about in this course as much. We're just going to accept it as fact for right now. You'll delve a little bit deeper into this in future math courses. But one cardinal rule of math is we cannot divide by 0. So instead of saying that this has a slope of 1 over 0, we say that this slope is undefined. Anytime you have a vertical line that goes straight up and down, it's going to be undefined. And that's going to bring us to the second part of the memory trick, the VUX. If we have V, that's going to stand for vertical line. We're always going to have an undefined slope. And it's going to be an equation of the form x equals some number. So anytime you see x equals a number and there's no y, it's always going to be a vertical line. Anytime you see y equals a number and there's no x, it's going to be a horizontal line. And anytime that you're just having a y equals x, you're going to break it down in a process similar to this. Alright, you guys go ahead and give these